They call the F-35 the invisible sword of modern air power, a jet designed from the ground up to disappear. Radar bounces where it shouldn't, heat signatures are tamed, sensors are fused, and data flows like a nervous system across the battlefield. It's stealth, data, and lethality in one sleek package. But every advantage creates a counter, and today we're pulling back the curtain on a family of systems the world calls, quietly, the stealth killers. Not a single secret gadget with a glowing red button, but a coordinated, high-tech approach that strips away invisibility. This is a story of the weapon that doesn't shoot down stealth so much as expose it. This is a secret that makes the invisible visible. To understand the counter, first we have to understand the cloak. Stealth aircraft like the F-35 are optimized to reduce their radar cross-section, minimize infrared emissions, and limit electronic signatures. Designers think in geometry, coatings, engine placement, and signature management. It's not magic, it's engineering. But it's engineering with limits, which is where the countermeasures come in. The secret weapon isn't one box in a weapons depot. It's a layered system that combines sensors, networks, electronic warfare, and inexpensive shooters, all working together. The idea is simple. If you can't see the jet with one method, see it with another. If one sensor fails, another will not. When systems act together, stealth stops being effective. Passive detection. Imagine listening for footsteps in a dark room without turning on the lights. Passive sensors don't broadcast, they listen. TV transmitters, FM stations, cell towers, and even lightning are background illuminators. Modern systems use sophisticated processing to detect tiny disturbances in those signals caused by an aircraft. This is called passive coherent location or passive radar. It doesn't alert the target because there's no radar ping, yet it can reveal an aircraft that tried to vanish from conventional radar. Multistatic and low-frequency radar. Stealth works best against high-frequency, narrowband radars that rely on specific geometries. But lower-frequency bands, VHF and UHF, interact with aircraft differently. They can reveal shapes that high-frequency bands miss. Multistatic networks, multiple transmitters and many separated receivers, make it harder for a stealth geometry to hide. Even better, separating transmitters and receivers by kilometers creates a geometry that the aircraft design never optimized for. Infrared and optical systems. Stealth is largely about radar. Heat is another story. Modern infrared search and track systems, IRST, and long-wave thermal images can pick up minute heat differences, exhaust plumes, skin friction, or the thermal pattern from skin-mounted electronics. Combine IRST with optical trackers and you have sighting systems that are passive, hard to jam, and deadly accurate at close ranges. Electronic warfare and spectrum dominance. If you can blind the F-35 sensors, you negate its strength. That means jamming GPS, spoofing data links, and injecting false targets into its sensor fusion. It's less about destroying the jet and more about turning its own information network into deception. An F-35 without reliable data is a jet with a perfect radar signature, but no situational awareness. Sensor fusion and artificial intelligence. Data from dozens, sometimes hundreds, of disparate sensors is fused in real time by machine learning systems. Tiny echoes from passive receivers, thermal anomalies, unusual radio reflections, and satellite cues are stitched together into a coherent track. AI finds patterns humans miss, raises the confidence of tentative detections, and guides shooters where to look. Cheap shooters and swarms. Once you've localized a target, you don't always need an expensive missile to take it down. Long-range surface-to-air missiles, air-launched standard missiles, loitering munitions, or even swarms of low-cost UAVs can be vectored to the area. The calculus changes. Instead of relying on a few high-value interceptors, you saturate the zone with many affordable shooters, making the enemy's survival odds drop quickly. Analysts, it's the network effect that's the real game changer. One sensor can be fooled. 10 cooperating sensors with instant fusion, much harder. Now let's put those pieces together into a realistic scenario. A contested island, dawn, radar stations hidden in hills, balloons and UAVs drift. Satellites track. Operators watch glowing maps. Satellites cue the area. High-altitude drones and aerostats loiter above the battlefield, carrying passive receiver suites and infrared payloads. Ground stations pick up subtle distortions in broadcast signals, a telltale signature that something with wings disturbed the IR field. Low-frequency radar arrays sweep, not to find a clear ping, but to collect fragmentary returns. AI fuses all this into a low-confidence track and keeps refining it as more data streams in. When the track becomes actionable, electronic warfare units zero in, targeting the F-35 data link and GPS jammers, and spoofers attempt to confuse the jet's navigation and situational picture. Meanwhile, swarms of cheap loitering munitions, guided by the fuse sensor network, move to intercept. If the F-35 climbs to burn less fuel and minimize IR, VHF radar catches a change in aspect. If it tries to hide behind terrain, passive receivers pick up the multiplied effects. There's nowhere truly dark once the net is closed. None of this is magic. Each element, passive radar, VHF arrays, IIST, EW, AI fusion, loitering munitions, exists today in some form. The secret weapon is a doctrine, distributed sensors, cheap shooters, and relentless integration. It's affordable, scalable, and resilient. You don't need to out-engineer stealth at the materials level. You out-architect it at the system level. Testing ranges, engineers calibrating gear. That's also why layered defense is frighteningly practical. A state or non-state actor doesn't require an industrial-scale program to buy a handful of off-the-shelf drones, a passive receiver array, and open-source machine learning models. Combine them with existing broadcast infrastructure, and you can build a surprisingly effective sensor net. When you add a disciplined EW capability and a method for putting cheap shooters on track, you've shifted the balance. But there are limits and risks worth noting. False positives. A sensor net that tries to detect the tiny signatures of stealth must be exceptionally good at avoiding mistakes. Mistakes can be deadly. Rules of engagement and escalation. Exposing a stealth jet is one thing. Shooting at it is another. Political and legal constraints shape how these systems are used. Countermeasures. Stealth programs adapt. Better emission control, improved sensor fusion on the aircraft itself, new coatings, and maneuver tactics can mitigate the net. It becomes a cat-and-mouse game where doctrinal innovation matters as much as hardware. Complexity. Running a distributed sensor network demands secure communications, robust logistics, and constant calibration. An adversary that can degrade the net's communications, cyber attack or kinetic strike, can blunt its effectiveness. What does this mean for the future of air power? Expect continued investment in signature reduction and data hardening on one side, and relentless development of distributed sensing and AI on the other. Expect more emphasis on resilient communications, multispectral awareness, and the humble drone, not as a single solution but as part of a larger system. For pilots and planners, the lesson is timeless. No advantage is permanent. The F-35's designers understood that when they emphasized speed, situational awareness, and network operations, those same principles apply to the counters. The battlefield will be one of systems, not lone platforms, and the side best at integration will gain the edge. Stealth was once the future's signature. Today, the future answers with networks. The secret weapon isn't a single missile or radar. It's the invisible net that finds what stealth tries to hide. In the end, invisibility is only as good as a world that chooses to see. If you liked our video, please hit the like button and subscribe to our YouTube channel.